Hi, I'm Stu from HiveMind Automation and welcome back to the Hive. In this DIY project video, we're going to be taking a look at creating reactive bias lighting for our TV using LED strips that I've shown you in previous videos. And we're also going to be using some software called Hyperion. So while I roll the intro, take a moment to subscribe and hit the bell icon to get notified when I release new videos each week. And let's get started. So we've spoken about LED strips before, and I've even shown you the LED bias lighting on my TV in previous episodes. But this time we want to make the bias lighting change based on what's on screen. Now, this concept of reactive bias lighting is not something new. Philips released Ambilight TVs years ago, but they've really struggled to catch on because they're not exactly cheap. If you're looking for a commercial product, you could also consider the Philips Hue Play HDMI sync box, but from what I've seen, it's temporarily out of stock. It costs $500, still requires a Hue bridge, and it only works with the Philips Hue lights. But it doesn't produce the same effect of kind of expanding the canvas behind the TV and improving the immersion of your TV or movie watching experience. With a little bit of effort and around about $150 Australian, we can set up an open source alternative called Hyperion, presumably named for the Titan god of heavenly light. And Hyperion integrates nicely with Home Assistant. Now, before we get started, there are some prerequisites that we need to consider. Obviously, we're going to need some LED strips, and I've got these SK6812 LED strips that I've demonstrated in previous videos. You're going to need a TV to attach them to. Now, in my case, we've still got our old 55-inch Samsung TV that already has the LED strips attached. We were using WLED and my custom board to drive those LEDs, but we're going to reuse those strips for this video and we'll take a look at that shortly. Now, for this project, we're going to need something a little bit more powerful than the Node MCU, and we're going to run this project on a Raspberry Pi. I've got this Raspberry Pi 3B Plus that used to be my Home Assistant server that I'm going to use. We're going to need an SD card for the Pi, so I've got this one from the Pi already. And to make the LEDs properly reactive, we're going to need a USB to HDMI capture card. Now, I picked this one up from Amazon for about $110, including postage, but the price does appear to have dropped to nearly half of that as of writing. I chose this one because it's 4K and 60 Hertz pass-through, and it's got HDCP built in, so it shouldn't throw any errors when we're watching anything from Netflix or any other copy-protected content, and still display our backlighting. One downside that I have noticed with this particular one is that it doesn't seem to pass through CEC, so the Apple TV can't control the TV and vice versa. Now, we're also going to need something to power all of this. We'll take a closer look at that a little bit later when we're in the other room and putting it all together. I'll put links in the description down below to all the things that I've used here. Some of those links will be affiliate links to help to support the channel, so buying through those affiliate links will help me out a lot. Now, to put this all together, I've got a bench set up in the other room with the old TV, but before we go and take a look at that, we're going to need to install the software onto the Raspberry Pi, and the quickest and easiest way to do that is to download and install the Hyperbian image. Now, if we go to the hyperion-project.org site and we search for Hyperbian, we will find the installation instructions here. So what we're going to do is go to Hyperbian download, and this is going to take us to the Hyperion project GitHub page where we can download this zip file which contains the Hyperbian image. I already have the Hyperbian image right here. This is just a Raspbian image with Hyperion pre-installed, and as you can see, it's available from GitHub, and I'll put these links in the video description down below. So we've got the Hyperbian image downloaded, and I'm going to use Raspberry Pi Imager to burn that to the SD card. So I'm going to click on operating system here, and I'm going to click use custom. So select a custom image from my computer, and on my desktop I have this Pi folder. I'm going to select this Hyperbian light image and click open, and we can hit cancel there. So we've got the Hyperbian light image. We're going to click choose storage. Now I need to pop my SD card into my SD card reader over here, and we see it's popped up here, so we'll click that. And we're going to click write, and we'll click yes. So while that's burning, I'm going to make sure that I've got my WA supplicant ready. And what this file does, if we put it into the SD card, we can define our SSID and our pre-shared key for our wireless network, meaning that we don't have to attach a keyboard and mouse to the Raspberry Pi to connect it to the wireless network. It just knows those details, and we can do that there. We'll see that we've got our country code here. Mine's AU. If you're in the States, you would use US. You can look up those 2-digit country codes for yourself. We would need to put in our SSID there, and we would need to put in our pre-shared key there, and make sure that we've got the correct key management type selected there. I've already created this WPA supplicant.conf file here. I'm just using this template so that we can demonstrate that. Okay, great. So it has finished, so we'll hit continue on that. Now what I want to do is make sure that I've got that mounted, so I'm just going to eject the card and then put the card back in so that we've got the boot drive there, and I'm going to copy WPA_supplicant.conf over to there, and the other thing that I'm going to do is enable SSH, and to do that I'm going to run in my terminal here, I'm going to run touch/volumes/boot and SSH. And all that's going to do, if we open up this boot folder here, inside here it will create a empty file called SSH with no file extension. You could achieve the same thing by just creating an empty text document called SSH and then removing the .txt file extension, and you'll see that we've got our WPA supplicant file in there as well. So now that that's prepared, we can eject the SD card and pop it into the Raspberry Pi, and we're going to pause the camera there. We're going to head into the other room and take a look at how the hardware itself is set up. So we'll be back in just a moment, and we'll be looking at the back of the TV. Okay, so here we are in the other room, and we can see the back of the TV and how I've got the LED strips stuck on the back. Now we do need to count and take note of the number of LEDs on each edge, and you'll see why when we get to the configuration of Hyperion. Now, I happen to know that I've got either 67 or 68 across the top and bottom, and 36 on each side. Now, the hardest part about this setup is power delivery, but there is a little bit of good news here, because these particular strips, the SK6812 and the Raspberry Pi, both run off 5 volts. So we can supply power from the same source, and in fact we probably should be doing so, because provided we've got the same ground on the Pi and the strips, we won't get a lot of noise in the system. Now in my case, I'm using this Meanwell LRS 200-5 power supply. It can supply 5 volts at up to 40 amps. This is complete overkill, but it is the best power supply that I had for this effort. I was trying to use an old computer power supply, but what I was finding was that as soon as the LED strips would turn on, the voltage on the 5 volt rail was dropping to below 3 volt when the LEDs came on, and that was causing the Pi to crash, because the Raspberry Pi will start throttling at anything less than 4.62 volts. With this power supply, the voltage is rock solid. So from the power supply, I've got these this 12 gauge cable. Again, this is overkill, that I've then soldered into the power inputs for the LED strips, which you can see in the corner of this frame here. And I've also hacked an old micro USB charging cable. This particular cable had no data lines in it. It was just a charging cable for, I think, an old Android phone of some kind. So we can use this to power the Raspberry Pi. We could power the Raspberry Pi by putting 5 volts into the right GPIO pins, but by using the USB input, we actually get some over voltage protection on the Raspberry Pi. So we will plug in our micro USB into the power port here. Now the next piece of the puzzle here is to connect the data input pin for the LED strips, and that's this yellow connector here, which I've then soldered a green wire on and put a DuPont connector. In my case, I need to put this on GPIO 10 on here. Now this is the 10th connector down this left hand side. I will put a pin out on the screen here. So we've got that there, and that GPIO pin is not going to be carrying a lot of current, so that small gauge wire is fine. And the last thing here that we need to do is plug in the USB capture card, and we're just going to plug it into any one of the USB ports. Now the HDMI ports on here, we need to put something into the HDMI input, and the HDMI output is then going into the back of the TV. And for the purposes of demonstration, I've got my old Apple TV here, which we're going to put into the input of the capture card, and then I'll run a cable from the capture card to the input of the TV. Now something that we should bear in mind here is that because we are using the HDMI capture card rather than any kind of native capture, we're only going to be limited to what we can run on one HDMI lead. For the reactive LEDs. Anything playing natively on the TV or through a source that's not running through that capture card is obviously not going to work. If, for example, you happen to have a surround sound receiver that can switch your HDMI signals, that should be able to run through this HDMI capture card on the output of that and then into the input of your TV, and that would solve that problem for you. So what I'm going to do is I'm going to plug all of this in. I'm going to pause the camera here, and we're going to spin the TV around so that the LEDs are firing at the wall. And then we're going to power everything up and get it set up so that we can actually see that. So I'll pause the video there and we'll be back in a minute. Okay, so we've got the TV on. Everything's plugged in behind the TV there as well. The HDMI capture card is plugged in between the Apple TV and the television itself. So you can see that that is doing its thing. It's passing everything through and we're not seeing any signal degradation, which is nice. So knowing that everything is set up and knowing also that the capture card won't actually be passing anything through if it's not powered, we can head over to the computer and we'll run LAN scan to find our Hyperion. So I'm going to search, so we can see we've got Hyperbian on 192.168.1.225. And just to illustrate something here, I'm going to run a port scan on here, and we'll see that we've got port 22, port 80, and port 8090. So SSH is enabled, that's port 22. 80 is just HTTP, and 8090 is the port that we need to access for Hyperion. So I'm going to open up Edge and I'm going to go to 192.168.1.225 on 8090. And we have our Hyperion set up, and we've got the default web UI password, and that's okay. I'm just going to close that, and we've got this first LED hardware instance. What I'm going to do is go to this LED instances and click LED output. Now by default we've got this controller type set to file. I'm going to change this controller type, so I'm going to choose SK6812 SPI and choose 0.0 as the device, and I'm going to set this baud rate to 4 million. There is a reason for that. I've found that the default of 3 million was flickering quite a lot. We'll leave the white LED algorithm as it is, and our hardware LED count is 208. I'm going to click Save Settings on that, and we're going to click Overwrite. And I'm just going to tick this Do Not Show This message again. And let's take this full screen, shall we? So we've got our 208 LEDs, our baud rate 4 million. Now we need to go to the LED layout tab here, and we're going to expand this classic layout LED frame here. Now, this is where we set up our LED strip layout. So we put 67 at the top, 67 at the bottom. Now you remember that I mentioned that we had those. 36 on the left and 36 on the right. I think that is correct. And I want to change my input position, because the input position by default, you'll see here, it is set to the top left of the frame. But in my case, the input position is this bottom right of the frame. So I'm going to put the input position at 104, and I'm going to tab out of that, and you'll see that that input position is in this bottom right now, but it doesn't look quite right. So if I change that to 68 and 68, that looks better. So it must be 68 across the top and 68 across the bottom. So if I quickly do 68 plus 68 plus 36 plus 36, 208. Yep, so it was 68, not 67. I had my count wrong there. So down in this bottom right here, we can also turn on the LED numbers, and we can turn on live video. Live video is not going to do anything just yet because we haven't configured our card, but I'm going to click Save Layout on that. So now that we've set up our LED instance and our LED layout, what we need to do is set up our capturing hardware. So we'll click on Capturing Hardware. I'm going to tick this box to activate USB capture. And in the drop down, we're going to select USB video, and we can also now select the device resolution. This particular device will capture at 1920 by 1080, but I'm going to change this down to, I'm going to leave it at 1280 by 720, and I'm going to turn my frames per second up to 10. I'm going to leave the size decimation and the crop alone for now. We're going to save that setting and the changes are now active. So if I go back to the dashboard here, we should be able to click on in the top right hand corner this Hyperion, and it's showing us what it thinks it's displaying, and we've got this live video, and we can see a preview of the live video, and that matches up to what's showing on the TV. Now I have a problem here in that my LEDs are not displaying as Hyperion thinks it is. So I need to figure out what's going on there. So I'm going to go to my LED output. I'm going to change this setting to 3 million and save those settings. And let's see what happens. Nothing. Change that back to 4 million. Okay, so I think what we're looking at here is a connectivity problem. So I'm going to pause the video there, check my connections, and then we will take another look once we've got it all hooked up correctly. Okay, so in the interest of full disclosure, it is the next day. I wasted a lot of time yesterday troubleshooting, and in the end, what actually solved my issue was I changed out the Raspberry Pi for a different Raspberry Pi. Everything else is the same. I'm connected to the same GPIO pin for the output of the LED strips, for the input of the LED strips. I did also swap the power supply. I happen to have another one of those LRS 200-5 power supplies, and I swapped it out. The interesting thing was I saw that the voltage on the Pi was at about 4.6 on the other power supply. It's about 4.8 on this one when it is powered up and running. And now we can see that the reactive bias lighting is working, and it is working as expected. Late last night, I also took some B-roll where you should be able to see the full effect of the reactive bias lighting. With this particular TV, it's a little bit difficult to see the full effect because it's not as close to the wall as I would like it. And that's by virtue of the way that the frame curves around behind the TV. But you get the idea. So now that we have the LEDs working, the LED strips working, over on our laptop here, we can go over to our effects configurator, and this is where we can configure different effects that we can use with the strips as well. So you'll see that we've got effect loader here. If I click load effect, we'll actually see how this effect is configured, and I can click on start test, and that's going to change what the LEDs do, and this one's called Atomic Swirl because if we look at the preview here, it looks like and if I click the live video, it actually just looks like a rotating, atomic symbol. And there are a bunch of different effects here. If I click on this drop down, we've got breathe. If I load that effect and then start that test, it's going to breathe the LEDs in and out. It's just a white color because we've got the same value on the RGB channels. Many others, there's things like Knight Rider. We'll load that and we'll start the test, and that is just a chase back and forth. Can go for police light single. We'll start that test, and it's just blue and red lights chasing each other around. And we can also go for a rainbow swirl, load that effect and start the test. And we can stop the test now as well. So once we've stopped the test, it goes back to using the USB capture. Now, obviously, this using this web interface isn't going to be particularly convenient. So what we want to do is integrate it into Home Assistant. So one thing that I have done here before we even get into that, I've got the power supply plugged in using this testing switch here, and if I open up the attributes of that, we can see that the load is currently at around about 12 watts. So that isn't too bad. I would have expected it to be drawing a fair bit more than that. I don't have a clamp meter to measure the actual draw from the LEDs, but I will invest in one of those at some point and maybe update the description when I've measured that. So what I'm going to do is open up my testing instance of Home Assistant, and we'll take that full screen, and we'll go to notifications, and we'll see we've got new devices discovered. We'll check it out, and we should have Hyperion here. If you don't have Hyperion show up there, you can click on Add Integration and search for Hyperion. I'm just going to click Configure on here. It's discovered everything that we need. So do you want to add this Hyperion Ambilight to Home Assistant? I'm going to click Submit, and we'll put the area. In this case, I'm just going to put the area in the spare room because that's where we are right now, and we'll click on Finish. So that has added the Hyperion to Home Assistant. If I head to our overview, and we will scroll through here, so we see we've got our first LED hardware instance, and it's actually giving us a preview of what is on screen as well. So it's passing through the USB capture. If I click on that, we actually get a live view of the USB capture, and if I click on the cog, we can see some details here. What I'm looking for though is this here, the switch. So the first LED hardware instance, we can turn the LEDs off, we can turn them back on. So what we can do now is I can click on this here, and we now have full control of the LEDs. So I can just set them to red, or I can set them to blue, or I can set them to green. And we can also change the effect here. So when we change that color, we got the solid effect, but we can go back to USB capture, or if we go to the drop down, we can choose any of those effects that we already saw before. So we had Knight Rider before. We have Pac-Man, and that's just a chase around the outside. It's not very bright. It's a bit hard to see because of the because it's daytime and the curtains don't fully block out. We can do Rainbow Mood, which gives us the full LED strip with the same color but cycling through a rainbow. Or we've got Rainbow Swirl, which gives us the full spectrum and rotates around or swirls around. And you might be able to see, if we close that, it has updated the preview there. If I just head back to USB capture, and so now that we've got this integrated into Home Assistant, we could use this in any of our automations as well. So for example, we could, when our burglar alarm goes off, we could call the police lights solid and then have red and blue lights chasing around the outside of the TV. Now there is also a mobile app that we consider if we search for Hyperion and tap there. And if we tap on settings, and we can, let me remove that one, we'll add server, and this one is on 192.168.1.222, and we'll hit done. And we'll drop that down. So we now have access to our Hyperion, and I can move around the color wheel. And I can tap on effects, and we can go to atomic swirl, we can go to color traces, we can go to any of the effects that we had before, and you get the idea. One thing I will say though is that it is very limited because for whatever reason the developer of the app made it paid to upgrade to premium, and it costs $7 a year to use the premium version. So honestly, I don't know that the app is actually really worth $7 a year. I'm sorry to say, but the free version does let you make some very basic changes to the settings on your Hyperion instance. So that's setting up Hyperion on a Raspberry Pi and integrating into Home Assistant. Now, despite the problems that occurred during the setup, I am really happy with the results of this test. I'm waiting on some more LED strips to arrive so that I can set them up on the new TV, and I'm definitely looking forward to watching some movies with those reactive bias lighting LEDs set up. Something I probably will do next time is use a logic level shifter on the output of the GPIO pin to make sure that the voltage that's going into the logic input of the LED strip is enough to make sure that it's actually doing the job properly. I have seen a lot of trouble with the data signal on these SK6812 strips because of the voltage of the logic level not being high enough. I'm honestly not sure why the SPI output was working when I initially tested my Raspberry Pi prior to shooting any of this video, but I managed to get it working on the different Raspberry Pi, so all is well. It's the same type of Raspberry Pi, it's a Raspberry Pi 3B Plus. There's no logical reason as to why it worked one day and then stopped the next. So I think that logic level shifter is the issue there, and maybe the LED strips just needed the voltage to be upregulated. That is all we have for this video, and I do hope that it helped you in some way in your home automation journey. Let us know in the comments down below if you want to set up Hyperion in your smart home, and any other home automation ideas that you'd like to see me cover in future videos. I'm working on some other projects regarding Hyperion, including a Raspberry Pi hat, so that you can easily connect your connections for the LED strips to that and power everything properly without a whole bunch of soldering and messing about. Don't forget to follow HiveMind Automation on Twitter, Instagram, and Facebook. And if you like this video, be sure to hit the thumbs up button down below. It helps us out a lot with the YouTube algorithm. If you're not already subscribed, please consider doing so now. And while you're at it, you might as well hit the bell icon so that you get an alert whenever I release a new video each week. Lastly, if you enjoy what I'm doing here and you want to help to support the channel, there is a Buy Me a Coffee link in the video description down below. Contributions through that Buy Me a Coffee link are put towards making more and better content for you to enjoy. Thank you so much for watching. I'm Stu from HiveMind Automation, and I'm looking forward to seeing you next time. Bye for now.